Okay. Good. 10i. Oh, let's practice one more the other way also, okay? So let's look at 29 and 30, okay? So now I want to write it, I'm going back the other way. So 3i was, if I rewrote it as a negative radical, a negative square root, right? Then I would have had a square root. The I was the negative. And then what did I take the square root of to get the 3? What did I take the square root of to get the 3? 9. Okay, so 29 and 30 we're doing the other way.
Oh, wait. So that's right what it was before.
Uh-huh.
Yes.
So what was 30 before?
25.
Just 25?
Negative 25.
The square root of negative 25. That's a 9. Okay.
Okay, I thought it was going to be words.
No, it's not too bad. You just have to get the hang of it. Okay, good? Are everybody good? Now we know how to work with imaginary numbers, right? Yeah, oh, sorry, Josh, question?
Yeah, like, when am I ever gonna use this, like, in my life?
To graduate high school.
That's
No, I'm just saying, like, when am I gonna
When you're
learn
counting
to do
apples,
five?
dude.
So if you become a mathematician and you learn how to program stuff, that's when you'd actually use this. But we live in a country that doesn't make you decide what you want to be when you're 10. And you get to go to high school and learn how to learn and do things that are hard, right? So asking me that is like asking your gym teacher, when am I going to do a sit-up in my real life? When am I going to need a push-up? We're training for things we might possibly do later. But I also think graduating high school is part of your real life, isn't it?
Yeah.
Mm-hmm. I feel as though I should have a mic and I should do a mic drop at this moment. No? That was a pretty good answer, huh? Yeah.
It's better than other people's answers.
Yeah, well, okay. Here we go. So, let's go back. Hold on. Yes.
What if you have like real numbers and imaginary?
What if I have real and imaginary together? That is what a complex number is. So, complex numbers are all numbers. Okay? So, every number is a complex number. So in reality, in the example 6 through 15 above, look, none of these were imaginary, right? But technically, I should have a C by all of them because they're all complex numbers. Every single number is a complex number. Okay? Every number is a complex number. Okay? Now, complex numbers have both a real and an imaginary part. It's just that sometimes their real or imaginary part is 0. So like on this one, I circle the real part of the number, but then I squared the imaginary part of the number just so I can tell them apart, right? Well, on 22, there's a real part of the number, but the imaginary part of the number is like 0i. It's not there, right? So if it's not there, then I know it has to be 0, okay? So then on this one, this is the imaginary part of the number, but my real part isn't there, so it's like plus 0, okay?
Wait, so what's 22?
Right here. So on these ones, it said to circle the real part of the number and square the imaginary part of the number. So that's what I did. I had to add in the imaginary part because it wasn't there though. Josh, does that make sense? Okay. We doing good? Questions? Okay. We're almost there. Go back to that Venn diagram.
What's that? This thing right here. Imaginary. Does that say imaginary?
Mm-hmm.
I don't know how to read that. You know, I sort of don't.
You don't?
Yeah, don't like being serious.
Okay, guys.
I don't even know how I needed this for. I'm surprised I can still swim. Complex.
What does that say?
Okay.
Bird.
Any questions? We got one more example to do and then it's homework time. What do you got? Doing good? Okay, so which of these classifications, no matter what, should be on every single one of your number classifications? The C, the complex. Good. Okay. Good, good, good. Okay. Last thing. Impedance is the measure of an object's resistance to an electric current or its opposition to the flow of current. Yeah, sounds physicsy. Complex numbers are used to represent the impedance of an element in a circuit. The voltage V is the real part of the number, and the current I is the complex part of or is the imaginary part of the number. So impedance is equal to V plus II. Okay, a certain element has a voltage of 18 volts. So is that 18 going to be the real or the complex part of the real or the imaginary part of the number? So, so that's not the one that doesn't have the I with it because that's the real part of the impedance. And a current of 2 milliamperes, it's a funny word, but that's the imaginary part of the number. So there's the complex number to represent that thing's impedance.
So you're just writing the equation, you're not.
No, I don't have to do anything with it. That's what you do in physics. I'm just showing you how to write the number. Okay, so can someone raise their hand and tell me what 32A would be? Yeah,
It would be 34 plus 3i.
you got it. So the volts is the real part of the number and the milliamperes are the imaginary part of the number. Okay, one more. Someone new, can you raise your hand and tell me what 32B would be? Yeah, Josh.
13 plus 2.4i.
You got it.
Oh, man.
What questions do you have? Anything? Guess what, you guys?